Greeting everyone. In previous class we have discussed about concept of current, free electron and relation of drift velocity with current, potential and electric field. In that we have discussed that I we can write Is this, and drift velocity can be written as this. And if you want to write drift velocity in terms of potential difference, we can write like, so there are many ways we can write it, right? And in which M is your free electron density and E is your charge of electron and tau average is average relaxation time. So, Ohm's law. It is not a new one. It was given around in 1600. So what is the Ohm's law here? Like if we have a conductor connected in a circuit, and there is some current through the conductor. Let's the potential difference is V. So this will be our electric field and current is going to flow like this. In this case, what is your Ohm's law? That the current which is flowing through the conductor is directly proportional to how much the potential drop is across the conductor. Means if the potential difference across the conductor will increase, the current through the conductor will also increase. And if we remove the proportionality, we will get some constant. That means del V over del I is constant. And you have already studied this law in 9th class. That is what Ohm's law, that in a circuit, if temperature is constant, temperature also has to be constant, then current through conductor is directly proportional to potential difference across the conductor. And if you see from the relation, it seems like pretty linear relation. Means if the potential is increasing by 2 times potential difference, then current will also increase by 2 times. Or if it is decreasing by x amount, then current will also decrease by x amount. So it is pretty linear relation, and it is only linear until we are talking about ohmic devices. And why we have to make temperature constant? If temperature is more at any material, if the temperature is more, it will not behave like ohmic devices. So del V or del I is constant, and if you remember something from 9th, you will also know that del V or del I is constant. That constant equals to your R, which is our resistance. And resistance, even though the formula of resistance it seems like it is del V or R, but it is purely due to conductor, and there is no role of V and I in this formula. Means even though if we can see that R is del over I, but R will be independent on potential difference in current. And you might think why is that and how is that, but I'll tell you in a minute, don't worry. So let's first discuss what is resistance before we proceed. Okay. So what is resistance? Resistance is just the measure how much hindrance a conductor can offer to the electrons which is flowing inside the conductor. It is the measure of hindrance or opposition offered by conductor to the charges flowing inside the conductor. If you remember, in Ohm's law also, before Ohm's law also, in drift velocity concept we discussed that if in any conductor, if current is flowing, electron is not moving in simple straight line direction, it is moving randomly, and it is doing continuous collision with kernels before it makes any significant displacement. For example, let's say if here we have electron and the electric field is in this direction to batteries, so it will move like this. We have discussed about this. Right? We have discussed about this. So this kernel, the collision with kernel offers what? Opposition to the what? Flow of charges in the direction opposite of electric field. This opposition is nothing else, it is our resistance. So the measure of the opposition offered by the conductor itself for the charges which is flowing inside the conductor, that is our resistance. And if we see the unit of resistance, so the unit of resistance is ohms, and we can symbolize by this, right? So it is nothing new. We have already studied that resistance, what is the resistance, and the unit of resistance is ohm. And I will tell you one more thing: any electrical device which you will see, any electrical device, it will have three fundamental properties. So any electrical device which you have already studied or which you are going to study, it will have three fundamental properties. In which one of the main one is resistance. Any electrical device you can have, it is going to be sure, it is must that it will always have some resistance. It can have more or it can have less resistance, but it will have some resistance. Similarly, it will have capacitance. Any electrical device, it will have some capacitance. Similarly, any electrical device will have some inductance. Two of the properties which you have already studied, resistance and capacitance. One is you are going to study. Any electrical device is going to have all the three properties, but if it has more resistance compared to two other properties, mean if the two other properties are merely insignificant compared to the other one, then the device is known as resistor. If it has more capacitance than the other two, then it is known as capacitor, and if it has more inductance compared to capacitor and resistance, then it is inductor. But in our syllabus, we study something like ideal electrical devices. In ideal electrical devices, if it is inductor, you will assume that it does not have any capacitance, it does not have any resistance. Similarly, if you study resistance, you will assume it does not have capacitance and inductance. But it is not to each device will have something. For example, our human body itself, it has some resistance. If you ever see meter or multimeter, if you hold one prong and another one, you will see your body has some resistance. It is around 400k or something like ohms. It will be around. And if you have ever like experienced this, sometimes we accidentally touch one of the end of live wire, but while we are wearing shoes, Still we feel shock even though the circuit is not complete. Why we feel shock? Because our body, even though it is not good, but it is somewhat conducting, and earth is also conductive, and we are separated by shoes. So current flows through us because we are sort of like capacitors, not good one, but sort of like capacitor, and AC current flows through capacitor. In upcoming chapter we'll study about this also, but I'm just giving an example that how our body is capacitor also as well as resistance. So in our syllabus we will just only study about ideal electrical devices, where it will always, if it is resistive then it will only have resistance, if it is capacitor then it will only have capacitance, and if it is inductor then it will have only. Now we are talking about Ohm's laws proof. We studied what is Ohm's law, but we need to see the proof of Ohm's law also. What I mean by proof of Ohm's law, that if I have a conductor and there is some potential difference, current is I, I'm saying resistance is change in potential over I, and it has to be constant, means the resistance of the device must not depend on V or I, it should be independent of V or I. And how we can prove it? But for that we have to assume few things. Our first assumption is again temperature constant. Why we have to make temperature constant? You will study in just some time. That if, or you can think it like that picture also I have shown by the collision. You can think it like this: resistance is due to what? Collision. And why we have collision? Because of thermal energy. Because of thermal energy, they have kinetic energy, they are moving randomly. So if the temperature is more, the collision is going to be more, the collision is going to be more rapidly. So what will happen? The resistance is going to increase. Similarly, if the temperature is dropping, they will have less kinetic energy, that means they will move not much random, and that means less collision, that means less resistance. So if we increase or if we decrease, the resistance is going to change, and the proof we will see will not be clear. So we want to make temperature constant, but and also if the temperature is changing, the dimensions of material will also change. We have studied in mechanical property of solid and thermal property of matter in class 11. So we have to make temperature constant. Also, if you study electrical engineering, you will see that when most of the time we don't use actually Ohm's law, because in many cases Ohm's law is not directly applied. It is only applied when the potential difference is small enough, not large enough. But in our syllabus, Ohm's law is valid everywhere. But once you go in higher class, you will study the difference. Okay, now right. Now let's see how we can prove that R is constant. Let's see what we have. I we can write as this, and drift velocity we can write as, in terms of potential difference we can write from previous class. You must remember, where L is length of conductor and A is cross section of area. Alright, so we have this formula. Okay, from this we can either substitute drift velocity formula in this equation, or we can use Ohm's law equation also. Anyhow we can prove it, but we will go by simple method. We will put the value of drift velocity in I equation, so it will be I, and instead of drift velocity I can write E del V tau average, and then the remaining terms E N N A. If you see, what you will get after simplification, you will get E square del V N A tau average for M mass of electron and length of conductor. So what we have to prove, that del V over I is constant, and we can see del V here and I here, so we can just do cross multiplication. So we will get We can write like this. I just did what? Cross multiplication, or if you do cross multiplication, this term is going to be there, and all this term is going to be denominator. That's what I wrote, and L and A I wrote separately. I'll tell you why I wrote L and A separately. Now see, if I'm saying we got this equation, and if I'm saying temperature is constant, if the temperature is constant, the dimensions of conductor will become constant. Right? Dimensions of conductor will become constant, and number of free electron density. What is number of free electron density? How you can get more free electron? If you have more thermal energy, more electron get ionized, and they will get more thermal free electron density. But if temperature is constant, your free electron density is also going to be constant. And tau average, just like I told you, if the temperature is more, they will have more thermal energy, and the collision will be rapid. So tau average will decrease. That means if temperature is constant, tau average is also going to be constant. What else we have? Mass of electron and charge of electron is always constant. There is no doubt in that. That means that temperature, if the temperature is constant, all the other variables we had will become what? Constant. So you get del V by del I equals to what? Constant, and that is what Ohm's law was. And if you see this constant equals to what? Resistance. So I can write resistance equals to what? The same thing, ME over NE square tau average times L by A. That is our resistance. And this particular thing has very special name, that is called resistivity. So we will get R equals to rho L by A. That is the formula you have studied in 9th class. So resistance and resistivity we just got to know right now. And what is resistivity we will talk in a minute, but you understood that resistance does not depend, you can see the formula, resistance does not depend on what? Current or potential difference. It only depends on what? Tau average, free electron density, and dimensions of conductor. Means it is just depending on the nature of material and dimensions of material, resistance. But if you see resistivity, it is only depending on what? Free electron density and tau average. That means it is only depending on our nature of material, not even on the dimensions. Are you getting it? So you can write it down, and we'll see about this more. Okay, after this, now we will talk about little bit on resistivity. Resistance we understood. What is resistance? It is just the measure of the resistance offered by any conductor, right? Or it is the measure of the opposition offered by conductor for the charges which is flowing inside the conductor itself. So what is resistivity? Resistivity is same just like resistance, but it is defined for a unit value. So resistivity is also known as specific resistance. It is also known as specific resistance. And what is specific resistance? Like, if you remember the formula, little bit that you have to apply. So imagine we have this solid cube, right? We have this solid cube, and the dimension of this cube is 1 meter. Okay, so if you remember that the formula of resistance is rho L by A, where L is the distance which current has traveled, the displacement, and A from the area of cross section where the current has entered. So if let's say current is entering from this phase and leaving from this phase, so what area will be taking? This area will be taking, right? And what length will be taking? This length will be taking. So in that case, if we see, the resistance will come out to be what? Rho. The length traveled by current is just what? 1 meter, and the area of cross section, this area of cross section is just what? 1 meter square. And if you simplify, you will get what? This will get cancelled out and rho will become equals to what? R, which is the definition of resistivity. So what is the resistivity? It is the resistance offered by it is the resistance offered by solid cube of 1 meter dimension or 1 unit dimension. So it is just the resistance of a cube when current is entering from one phase and exiting from the phase opposite of the first phase. Then the resistance will be called as resistivity. So what is the resistivity? Again, it is the okay. So what is our resistivity? It is just the resistance offered by a cube when current enters from one phase and exit from the other opposite phase. Then the resistance offered by the cube is actually equals to resistivity. And if you see from the formula, the unit of resistivity is going to be what? If you see from the formula, this is already ohm, and you can see 1 meter will be left and it will become ohm meter. So the unit of resistivity is ohm meter. For a material, resistivity is constant. Resistivity is constant because it is defined for 1 meter cube or unit thing. That's why it is constant. Just like you can think of like this also, molarity also. Like once you have molarity, it is defined for some 1 milliliter volume, and even then if you take a small section of this solution or you take the complete solution itself, the molarity is going to be same. Similarly, if you take a small chunk of material or the complete material itself, the resistivity is going to be same because it is defined for a unit value. And why we need this? Once you know the value of unit value, you can get the resistance of any arbitrary value of material. Let's do quick recap on Ohm's law again. So what was the Ohm's law again? Delta V equals to IR, right? We can write like this also. That means if I plot the graph of V versus I, potential versus I, then the graph is going to be straight line. That is the theory of Ohm's law, because from this we can see the potential and current has linear relation, and the slope of graph will tell us resistance, right? Slope of graph tan theta, which is just slope, will tell us resistance. But it is only true for ohmic devices. What is ohmic devices? Any device which follows Ohm's law or for which the graph of V versus I is straight line graph, that is our ohmic graph. But most of the time the graph is not, materials are not ohmic. For example, if we talk about non-ohmic, for that we can take semiconductor also. Right. So if you check their graph, that graph is not linear at all. This current and it is our potential. So if you see the graph of non-ohmic device, the graph will not be linear because they don't follow Ohm's law. Right, you can see the graph is not straight line. Either we have V versus I graph or I versus V graph. If the device is ohmic, then the graph should be straight line. But if it is not ohmic, then the graph will not be straight line. Even though if we take a metal also, which should be example of ohmic devices, just what, like metals, for example copper, aluminium. But even these metals are only ohmic if the temperature is small enough. If the temperature is increasing, keep on increasing, their graph also will not be ohmic. Right? So you can see up to this point the graph was ohmic. Here it becomes non-ohmic. And it happens, even any conductor you can pick, it is not ohmic if the potential is high enough or the temperature is high enough, then it will behave like any non-ohmic devices. So your Ohm's law only valid if the temperature is small enough, like room temperature around something like that, or the potential difference is small enough. But for 12th class, if you see any conductor like metals and all, you can assume it to be ohmic. Only in engineering you will find the exceptions. Let's do little bit easy questions on Ohm's law. Like if I give you the graph like this and this, if I say this angle is 60 degree, this angle is 37 degree, it is material A or conductor A and it is conductor B. Okay, this graph of I versus V graph, and I am saying A and B are two conductors. Then you have to find resistance of A and resistance of B. What will be resistance of A and resistance of B? Tell me. You can try. In this type of question, it is not that difficult and it is common. Like in both type question they can ask, and early like not recently, but in the like early 2000 or 2010 they used to ask in JEE also. But this is very IIT-JEE type exams. But this is pretty easy example. But still, student can do mistake. What they can do, they can find slope and they can write slope is R, which is wrong here because it is not I versus V graph. It is it is not V versus I graph. It is I versus V graph. Here the slope means tan theta will not be equals to resistance. It will be 1 by resistance. So that means resistance will be 1 by tan theta. That means resistance of A will be our 1 by 37, 1037, and resistance of B will be 1 by 1060. Right? And there you can evaluate what is 1037 you should know, and 1060 you should know. This is this very special triangle, you should know 5, 4, 3, 53 degree and 37. You can remember the values easily, and 1060 you all know what is the value. Got it? Okay, so imagine this is your solid cuboid, resistivity is 0, and if the dimensions are like this, A, B and C. Okay, so if the current is entering like this and leaving like this, so in that case what will be our resistance? Can you tell me what will be our resistance? Tell me. If you see in this case, the resistance is rho L by But what L you can take? From which cross section current is entering? This one, and which cross section is leaving? This one. So what is the displacement between these 2 points? It is just your B. So rho L by A. So L becomes here B. And A is what? Area of cross section where current is entering. So current is entering from this cross section, and if you see the area of this cross section will be just A times C. Okay. But if in the same question current enters from this end and leaves from this end, then what will be our current, or what will be our resistance? In this case, you can see the displacement which is made by current, it is just A. So L becomes A and area becomes this, and this area is just R what? It is just B times C. Okay. It is a fairly simple question, but in that type of question, what we have to assume that current is uniformly distributed through the area. Otherwise, this question can be a little bit tricky. Okay, so I will give you one question to try. Otherwise, we will discuss in the next class. So this is the question you have. This is the question you have. This is these 2 points are the center of each square face. It is just like a pyramid, but the top end has been chopped and the base is square. So base is here B, 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 and B. This coordinate, this point is center of this point, and all the points are A, and A. So current is entering from the bottom face and leaving from the top face. So, and resistivity of material is rho, and it is solid. You have to find the resistance, and this separation between the top and bottom point is your L. So you have to find the resistance of the material. That is your homework. In next class we will be discussing more such questions.